All right, everybody, thanks for being patient there. We are going to kick things off. I appreciate everyone joining me today. We will be discussing the video detection and continuous counts within Miovision Traffic Link. First off, we'll do a quick little introduction. My name is Rob Molinaro. I'm a technical account manager with Miovision. So I'm responsible for a lot of what we're going to talk about today: configurations, troubleshooting, some more of the advanced custom things that you can accomplish within Traffic Link. I've been working with Miovision for almost 2 years exactly. I come from a background of software. I've worked with Apple in the past, and more on the technology side. So traffic was quite new to me. So I've learned quite a bit in the last 2 years, and hopefully brought some expertise from the software side to the traffic side, and been able to marry that in what we're able to accomplish. We are going to have 10 minutes at the end of the webinar for questions. Otherwise, we're happy to follow up with you directly, especially if there's anything that's more detailed or specific. You can always reach out to myself at rmolinaro@miovision.com, or you can also contact your local distributor of Miovision products, our sales team, or our support team directly for any questions, concerns. We're always happy to chat. So to go over today's agenda, we're going to do a quick recap on our hardware and how we enable detection within the intersection, how our counts work as well. We're going to lightly touch on helpful concepts. So basic intersection operation, I imagine that'll be a review for a lot of people, but they are important to go into the platform with. Third on our agenda is going to be within Traffic Link. We're going to talk about intersection configuration and devices. Next, we'll talk about what presence detection is and the configuration for presence detection. And then lastly, we're going to look at crosswalk and multimodal turning movement count configurations. So we're going to walk you through the whole process of getting detection and count set up today. It's a fairly straightforward process, but it does have a number of steps. So we want to make sure that we can guide you through in a very smooth way. So first, we'll kick things off with a little overview of Traffic Link. So Traffic Link truly is our web-based portal where you can access any of your ATSPMs, you can see your intersections, access counts, and get a visual on detections, see camera feeds. So truly, Traffic Link is actually the website that you access to see all of this. But there's a couple components that are important in making Traffic Link operate and work. So firstly, we have the Miovision Smart Link. So that's the device on the left here. The Smart Link functions as a 4G and LTE modem. It's also an in-cabinet switch. So it's the device that takes care of any of the communications going on within the cabinet. So it's going to pull in telemetry and data from the controller itself. It's responsible for letting the video feed go up from the Smart Link into the cloud and then back down to the user on Traffic Link directly. Next up, we have the Miovision Smart Sense. So that is our detection processor. So that also exists in the cabinet. We go from the controller to the Smart Link. Smart Link's connected to the Smart Sense. The Smart Sense connects back to the controller through SDLC. And the Smart Sense can be thought of as kind of the brains of the operation. It's responsible for doing the actual detection live through the device. It has 2 GPUs, so it's a pretty powerful unit that's taking care of the vehicle, pedestrian, bicycle detection. And it's accomplishing all of that. I like to call it the eyes of the operation with the Smart View. So the Smart View 360 is a 360-degree 4K camera, and it does, as many people would know, what a camera does. It's able to give you a visual on the intersection. The nice part is it has that 360-degree field of view. So in a lot of cases, you only need a single camera to be able to see most of the intersection. And then lastly, the traffic link portal, that's going to be the, I would say the user accessible piece that most people are used to using. And again, traffic link houses quite a bit of data and information. That's why today we're focusing specifically on one part of that, but we do have other webinars where we focus on signal performance measures and some of the other things you can do within traffic link. So here's a quick diagram view of video detection as well. And so you can see down here in the cabinet, we've got the controller itself. We've got the Smart Sense and Smart Link right next to it. They are communicating up to the cloud. And again, here's the user accessible view. And then the camera is mounted on, in this case, could be a signal pole, luminaire, mast arm. As long as the camera is mounted up high and has a good view of the intersection, you've done a good job with it. So next we'll go into intersection design and operational concepts. So a few helpful concepts to understand going into this are intersection phase design, and that would be how intersections are commonly set up. There tends to be, I wouldn't call it a rule, but a general rule for how people like to design intersection phase diagrams. So we'll chat a little bit about that. Phase to channel assignments. So again, not a straight rule that you have to follow for assigning a channel to a phase. We're basically mapping the two together, but a good general approach that most people like to follow. We'll chat a little bit about what a presence mode detector is. We'll talk about pedestrian counts and how they operate. We will talk about turning movement counts, or TMCs, and we'll talk about turning movement heat map validations. So that's something fairly new to the platform that not everyone, even if you've used it before, you may not be familiar with that. So intersection phase design. So a lot of this will be, again, quite familiar to some and not so familiar to others. But intersection phase design tend to have each approach add up to either 7 or 11. It's commonly called the 7 or 11 rule. So the minor streets tend to add up to 11, and the major streets tend to add up to 7. So you can see here, phase 4 is the through and right turn. Phase 7 is our left turn movement. You add those two up, you get 11. And on the major, we have 1 and 6, totaling 7. So this is a pretty standard diagram for an intersection with 8 different phases, including the 4 pedestrian phases as well. On the right here, you can see a timing plan, part of the documentation that's been provided to us to help configure the intersection. So we do need to know how the intersection operates in order to map the detection properly. So you can see on the documentation we have here, this timing plan is a pretty nice detailed one. You know, it's laminated. I believe these exist in the cabinet for the municipality we're referring to. I've had people provide me timing diagrams that were written on napkins, and then they snap a quick picture. So again, not all of them are as formal as this, but good documentation always helps as well. When we talk about vehicle zone to phase association, this is talking about how people generally like to associate the vehicle or the movement phase to specific detector channels. So most of the time, we like to do a one-to-one association for them. So if the northbound left turn is phase 1, the easiest way to map it is detector channel 1. Again, this is what I would call a best practice or a common practice. It is not a rule. It doesn't have to be done every time. but most locations, you can generally assume that this is how it's mapped. And each detector rack, which you can see here, has 16 different channels. So right now we're on detector rack 1. You can see it has 16 channels. If we move to detector rack 2, we get another 16, and continuing on. The Miovision SmartSense is capable of using up to 64 channels. So we give you quite a lot of options and customizability. And of course, what you're going to want to do is make sure you know what the controller configuration is to map it to the channels or detectors within Miovision Traffic Link as well. So here is an image of presence detection in Miovision. So you can see we've got a nice camera view of an intersection here. And in the blue, we have different detectors that are going to be looking for vehicles to drive into them or be within those zones. Same thing would account for bicycles, buses, motorcycles. We're just looking for any form of a vehicle to enter those zones. And then the SmartSense is going to look at them. It's using a combination of computer vision, AI, machine learning, all of those fancy buzzwords that are common these days to determine what a vehicle is. So we're looking for specific characteristics. When it comes to a vehicle, we're looking for headlights, the general shape, perhaps a windshield, tires and axles. There's a number of different things that help us identify what a certain vehicle is. And a lot of that's all done just from the millions, if not billions of vehicles we've seen through our platform over the years. One nice thing with the computer vision and AI is that the more we see, the better the detection gets. So we're at a point where our detection operates incredibly well. But again, it's only going to keep getting better over time. So in this scenario, we've set up lane by lane detectors. So it looks like the 2 through movements are their own detection zones. And it looks like we actually have what is probably a protected right turn here. So that has its own detection zone, and that's going to be tied to its own phase within the controller. With our platform and its capability for multimodal detection, it's also looking for pedestrians. So you can set up crosswalks within the platform. We do give you bidirectional pedestrian accounts, or bidirectional pedestrian accounts. I apologize. And the nice part is it's both doing counts and it's also looking for pedestrian occupancy. So part of how this works is part of our safety feature. It's actually taking a look at whether the walk, flashing don't walk, or don't walk symbols are active on the pedestrian signals. And as a pedestrian walks through the crosswalk, if it registers that they've walked through there while the flashing don't walk or don't walk indicators are up, it's going to help populate a chart for compliance. Basically let you know if somebody's jaywalking or crossing at an intersection when they shouldn't be. Another interesting way to use this, and we've seen this in common places, common roads where people cross in front of, say, a football stadium or something like that. You can map a crosswalk zone further up the actual road if there's lots of people crossing there, to get an idea of the number of people crossing there during a football game or a concert outside a major stadium. So I mean, the platform itself has some very specific detection capabilities that it's intended for, but thinking outside the box and getting creative can also be very helpful in the platform. And we're also able to help you out with situations like that with more unique needs. So next up, we have the turning movement count, or the TMC configuration. You'll have all 16 typical movements that are available in a configuration. So you can see we've got a left and right here. So left here, right over here. We've got lane by lane for the through movements. And we also have a U-turn. So again, this is going to be counting from the approach that they've entered on and where the vehicle exits. So we're not just giving you, an approach counter. We're making sure that that movement is actually completed. So that very much helps with accuracy. The other piece that helps out with accuracy is when the tracks are drawn lane by lane. So you can see in the through movements, we've got through 1 and through 2. And that's just for accuracy. Sometimes vehicle movements aren't always exactly as you'd expect them to go. Sometimes people swerve or make interesting decisions in a lane. So that's why you want to track both lanes. Now, when you actually look at the turning movement counts, it will aggregate that data by movement. So through 1 and through 2 will both be combined into a northbound through. We also have what we call the heat map validation process. So this is something that's actually been really, really helpful to me in my role, because a lot of my job is helping people with configurations, making sure turning movement counts are accurate, making sure things are set up properly. And in the case of this intersection, we're looking at a pretty standard four-legged intersection. It's not going to be too hard to predict how somebody's going to move. Like if you look at the eastbound through movement, you can see how we've drawn our turning movement count in the kind of the orange-yellow line here. But highlighted in blue is actually what I call a validation of that. So after 24 hours, we get the heat map, which is what we're seeing here in blue. And it's going to show you exactly how vehicles are traveling through that intersection. So this is really helpful in the case of a non-standard intersection, intersections that aren't exactly north, south, east, west, intersections that might not be striped or painted properly. So or in cases even when there's lots of snowfall or something like that, you can get a general idea of the typical movements in that location. And therefore you can make sure what you're looking for in your counts are accurate. So when it comes to actually planning how to integrate the detection into the intersection, you do have to plan for the camera's location. So the camera can be mounted on a number of different surfaces. I think I said a little bit earlier, you could mount it on a mast arm, a luminaire, a signal pole. You could mount it on its own pole if you really wanted to. But the prior three things I mentioned are where we typically see cameras mounted. We typically recommend a height of about 30 feet for that installation. And when the camera is mounted at 30 feet, you're going to get about 150-foot field of view to the front of the zone, and at furthest back, about 190-foot field of view. And of course, when you're planning for your camera location, you want to avoid any occlusion. So you want to avoid putting a camera right where maybe you're installing a camera in the spring and it looks like a great location there, but you do want to plan for potential trees that grow in the summer or something like that may block the camera. So the maximum detection radius is going to be around 190 feet if your camera's at 30 feet high. So you can see we give you a pretty good radius or overall field of view of this location at Belmont and Gage Avenue. Now, this happens to be a relatively small intersection. When you look at a much larger intersection, and I'm familiar with this intersection, this one's in our local area, it's just coming off a highway, lots of traffic here. On the left, you see it's a big plaza and shopping center. So in an intersection like this, you can actually utilize a dual camera setup. So for large intersections, you go ahead and install one camera. I would say typically in the Northeast and typically in the Southwest or Northeast, Southwest, whatever again, whatever's going to be the optimal placement to avoid occlusion and still see all four approaches. But you can see the camera in the north here has a great field of view of the north and east, and the south camera can do the south and west. All right, next up, we're going to jump out of the presentation and go directly into Traffic Link and go through a little configuration right there. Perfect. I just wanted to make sure my my screen was still showing. So everything looks good on the technical side, and we can continue on. So when you first log into Traffic Link, you'll log in with your username, your password. It's going to take you to what we call your organization. So that could be a city, a municipality, a small township. It really depends on how you want to set up that organization. So it's fairly customizable depending on what's going to be the easiest way to organize it for you guys or for the city or whoever's actually managing the signals from there. So we're actually located in the Waterloo region here. Miovision's head office is just in Kitchener, somewhere in this area. We actually have a pretty large deployment in the area. And I'm going to be looking for a pretty specific intersection. You can see any of the dots here are intersections where some of our hardware is installed. Any of the ones you can see with the camera icon are, ones that likely have detection up and running, and any of the gray ones are ones that are planned to be an install sometime in the near future. So they're created, but the hardware is not installed yet. On the left, we've got a summary of all the locations. In our case, I know exactly what we're looking for. So we're going to be looking for Cortland and Blockline. So you can just use the search at the top to isolate any intersection, especially handy when you have a large deployment like this. And we're going to select that intersection. We get a nice handy overview of the location, and then a few other details, some of the weather, which is quite chilly. -8 degrees Celsius is it's not a warm day. There's lots of snow on the ground, let's say that. And then down here, you can see all of the devices that are installed at the intersection. Now, in this case, this is a pretty detailed setup. There's lots of non-Miovision devices in the cabinet here. So don't be too intimidated by seeing this list. This is just more of a very advanced setup with everything that's been plugged in. We're not going to worry too much about that in what we're doing today, but it really does speak to the ability for our products to integrate with third-party devices and other devices that you can typically find in cabinets today. So all of the navigation is done on the left bar here to navigate through Traffic Link. Again, there's a number of different options. We are not going to go through all of them today. Otherwise, you'd be spending 3 or 4 hours with me for a full run through. But we're going to highlight configuration specific options. So we're going to go down to the devices page here. And as I said, there's quite a few devices in this location, but there's a few specific ones we want to focus on. So we've got the Miovision SmartLink here. We have SmartView 360. So we've got one camera, and that's named the north side camera, or SmartView 360 north side. We've got the SmartView 360 south side, and then we've got the Miovision SmartSense serial number and status or connection details here. So each of these individual devices can be edited just by selecting the 3 dots on the right. You can see each one of them has their own submenu. In this case, we're going to be looking at the SmartSense, because the SmartSense, if you remember, is responsible for the detection and taking the inputs from the SmartView and outputting them back to the controller. So if we click on edit, and of course this device is already set up. This is actually a live intersection, so I'm not going to play around with it too much or change anything. It's just to give you an idea of how everything operates. You have a couple different options for the configuration. So you've got ABC, which is more of a legacy configuration with older controllers. We very rarely see that. SDLC is, I would say, 99.9% of our installations. Very common way to connect to a controller. And then GPIO, so that's a wiring harness to connect to a controller. General purpose input output, if you've heard it referred to as that. That's a rare setup as well, but still used out there in the field in my experience. So secondly, we have to choose which channels we want to use, which detector rack. So we touched on this a little bit earlier. This is typically information we'd have from a signal tech or somebody who's defined how the intersection's set up. We could also formulate the detector channels being used here and then program them into the controller after. I think the important takeaway is as long as they match, you will be good. So in this case, we're using detector rack 2, which is channel 17 to 32. Now, I'm not 100% familiar with what's already installed on this intersection. They could already have maybe older detection that's still there on detector rack 1 to 16 that they're not actively using, but maybe they didn't want to pull out. So maybe it exists there as a backup or something like that. But the region of Waterloo has opted to use rack 2 in this case. One of the other nice things that you can do is you can actually remote into a controller. So this can be helpful for configuration. Let's say we had a tech out at the intersection, they installed all the Miovision gear, but you're not ready to set up detection, or maybe you're not ready to turn on the detection and actuation. But you really don't want to send a technician back out there just to make a few changes on the controller. So where the controller's set up, and again, you have to set it up with knowing some of the documentation for the controller, but you can actually connect to the controller and make edits and changes directly to the controller through Traffic Link. Yeah, so there we go. We've got a pretty standard controller status window here. Again, I'm not going to play around with the controller, but you could go ahead and make changes to the detection, and you don't have to have somebody on site. So you also get a pretty convenient approach right here. So next up, we're going to take a look at the telemetry. So we're going to do a rough overview here. We're not going to dive too deep, but the telemetry screen is pretty important. I like to look at this as the general status screen. It's kind of your command station for everything. You get a view of the traffic signals and which phase and name they are. You can see the status of the pedestrian signals. This location is actually tied into preamps. This is a pretty important location for our light rail transit through the region. And then down at the bottom, you have all of the detectors view. So the detectors, you can see some of them are lit up in a dark gray, almost a black color. Some of them are a light gray. Anytime that they turn dark gray means that detector is being called. There's the presence of a vehicle in that zone that we have set up. You might also notice the mini map on the right here. This is more of a visual view of everything, of what's happening at the intersection. And you can see any of the zones here. They're highlighted in black. If you see them flash purple, as you can see on the west side of the intersection, that means somebody's also in the detection zone. Oh, and there we go. We've got our light rail preempt firing right now. Truthfully, that was really just good timing. So again, this is kind of your general overview of how the intersection's operating. You can also get a historical view as well. Right now we're looking at the time right now, February 15th, 1:32. You can use this timeline to go further back and see how things looked. So if there's ever a citizen complaint or anything like that, you can get a historical view of the signals, detectors, all of that, and it gives you something to be able to at least speak to. All right, next up we have the video tab. So with our detection, we do give you a live stream of what's happening at the intersection. So I could pull up let's say we're going to take a look at the north side. There we go. As I said, we've got lots of snow on the ground. There's the light rail coming through right now. And again, just gives you a general view of what the camera's seeing right now. You can actually pull up a side-by-side view with both cameras if you wanted to. We also give you the detection overlay view. So I'm just going to let this load here, and I'm going to put this in full screen and give you a bit more of a detailed explanation of the detection overlay view. So in the top left window, it says Cortland Avenue East, northbound. And you're going to see a couple things here. So the main thing is there's yellow boxes. Those are our detection zones that have been manually drawn and set to look for vehicles. When those boxes turn green, it means they're detecting the presence of either a vehicle, a bicycle, a motorcycle, could be any motorized vehicle. And around each individual vehicle, it's getting classified. So the blue box is the classification for vehicles. You can see here we've got vehicles flagged as V1, so light vehicles. And then at the back here, we have V2. So that would be a bus or a heavier vehicle. The other thing we have here is there's a yellow zone that's been drawn, and you can see it's got a purple line in there. That is a pedestrian counter. Can also be set up to be a bike counter. Basically, it's counting the presence of anyone in the crosswalk and letting us know how many people have crossed. But again, by default, it's a pedestrian count, but again, you can get a little bit more custom in some of the configurations and set that up to also look for bikes. If you get a lot of bicycles crossing at that point in the intersection, maybe there's no bike lanes, and that's what pedestrians or bicycles choose to use. And there we go. Actually, on the top right, we've got some pedestrians. That's good timing too. This isn't a very pedestrian heavy area. It leads to, I mean, there's lots of restaurants. There's a shopping mall not too far from here, but it's a very vehicle and light rail centric area, not so much pedestrian. All right, in the bottom right here, you see what looks to be a lot going on, but this is actually our turning movement count. So very similar to the pedestrian crossing and the pulse counts. With the turning movement count, this is looking for the movement of vehicles. If you remember when I talked a little bit earlier about the turning movement counts, it's actually counting the actual movement of the vehicle. It's not just, looking what lane they entered from. It's actually looking where they entered from and where they exited. So we're going to help you differentiate between whether a vehicle entered the left turn lane and actually made a left turn, or it entered the left turn lane and did a U-turn instead. So all of these just add one to the counter every time it pulses. You can see as a number of vehicles go through, it's counting quite a few of them. So the video itself is recorded. The Smart Link device actually has a small hard drive in there. By default, it's a 60 gig hard drive. And the video recording kind of functions, if you're familiar with the dash cam, it functions the same way. So it actually does a recording of everything and then continues that recording for approximately the past 7 days. But when the memory's full, it's going to erase the oldest recording and overwrite that. You can choose to save the video recordings a bit longer. So under the video recording page, you can use the checkboxes and you can, what we call recalling a video. So that will actually upload it to cloud storage and save it permanently for further retention. I mean, that can have various uses depending on what you're trying to do within TrafficLink. I mean, in some cases, we have police services who have access to the platform and they want to be able to see vehicles. So all really depends on usage. I think one important thing to note as I say that is the camera itself cannot, it doesn't have a high enough resolution to look for license plates or identify people or anything like that. So from a privacy standpoint, you know, we're not a security camera, but we can give you general information about what's happening in an intersection or in the case of a collision or something, how that happened. So I just wanted to make that clear as well. Now, the next page is Insights. The next little bar, or the next little icon on this bar is our Insights page. So if we click on here, again, you get quite a few options. These are related to various signal performance measures and optimizing the intersection's performance. Today, we're focusing on the continuous multimodal counts. So if we move over to here, we can pull up the actual turning movement count data. And being completely honest with you, it does take a few seconds to load. It's got a lot of data in there. So I always advise being patient with this page. But this page does give you a lot of information as well. So right now, we're looking at yesterday, February 14th, 2022. We're looking at a 24-hour period. And we're giving you a breakdown of pretty much everything that happened at the intersection within that 24-hour period. So you can see we had 20,000 vehicles go through, 245 pedestrians, 4 bicycles. Yesterday was bitter cold, so there must have been a brave 4 people going through on their bicycles. And we also give you a truck percentage count, as well as AM and PM peaks. In the bottom left, you get a more detailed breakdown of exactly which movements occurred. So you can see 6,107 people went through from the south to the north, so going northbound, 17 U-turns, 1,776 lefts, and that's all done just by highlighting the specific movement. On the intersection count page, we give you a very detailed bar graph breakdown. Light vehicles, motorized vehicles, single unit trucks, articulated trucks, buses, bicycles, and pedestrians. So if you wanted to get a specific idea of when pedestrians were walking through the intersection, you can disable all of these. Oh, you know what? We could leave, for example, pedestrians and bicycles. So we can see there's a lot of pedestrian traffic between 5 and 5:30. And I mean, that's 9 people. As I said, this is not a very pedestrian heavy intersection, but we can get a good idea of all of that. And then lastly, you can export the data in either into a, I believe it's a CSV typified export. So 15-minute bins of aggregate turning movement count data. You can also do bin data, which is going to give you the entire configured duration in 15-minute bins. You can go ahead and change the date range as well. So if you wanted to get a breakdown of what things looked like, you know, last month, last quarter, a specific week in the last quarter, you can go ahead and do that. And that pretty much sums up the turning movement counts. I know, again, you get a lot of data there. So a lot of data engineers and traffic engineers love having this information for various different studies. In some locations, we have people who have set up our units as almost like a traffic count station, you know, going into a stadium or something like that. So obviously the product can do a lot more than just that, but that is a heavily sought after function, and we give you very accurate data with that. All right, so lastly, we're going to go into the actual configuration. That's just on the bottom left. I'll show you how to configure everything within TrafficLink. So as we talked about a little bit earlier, we had to do phase associations to set everything up. So we're going to go into the actual configuration of the detection, assuming we have all of that entered and set up. So you'll navigate to the top right and choose Configure SmartSense. And you'll be met with typically a screen that says, it shows you one of the cameras itself, and it's going to ask you to create a new configuration. In this case, we already have one that's been uploaded by one of my colleagues. We're going to go ahead and create a new one, but not deploy it or save that. So this location actually has 2 cameras, and that's from taking a look at it, just because it's a bit of a larger intersection. I know they wanted a bit of a view of the LRT as well. So installing 2 cameras in this location was what the customer wanted for it. I think we probably could have done just detection with a single camera, but again, there was an additional use case here, so 2 cameras were installed instead. So when you get to the configuration page, it's going to ask you to initially configure the camera. So we can go ahead and click on configure. And the first screen we're met with is helping to de-warp the camera to help set the curvature of it. So the camera itself is a 360-degree camera, but depending on the angle it's installed, it could completely warp the camera's field of view, depending on how it gets physically installed. So what we want to try and do is highlight the center point of the camera, which is this little blue dot here that I'm moving around. And we do that by finding points within the camera's view that are going to line up and be parallel with these lines. So for example, in the top left here, if we follow this blue line, we can see there's a signal or a signal pole, both actually, but it lines up very well. It's parallel to that signal pole. So that looks pretty good to me. Another point of reference could be this pole here, and we've got various other ones here. So this camera is actually installed very well. It's pretty much flush with how it's supposed to be installed there, and the center point is directly below, meaning that the camera's field of view has no curvature or warp to it. The next step is to confirm how high the camera was installed, and this is to help determine what the camera itself is looking for when it's looking for a vehicle. I mean, if it's installed at the bottom of a pole, it might be looking for a vehicle this size, for example, which is not a good installation, not something you want to aim for. So if you know the actual camera height, you can go ahead and type it in here. And for anyone that's not in Canada, it does not have to be in meters. It can actually be set imperial and set in feet. Funnily enough, despite being Canadian, I mostly talk about height in regard to our cameras in feet. And this little icon here is just to help you estimate. If you don't know exactly how high it's been installed, you can go ahead and move the bar up. It creates this little wireframe car, and it's about the size of a Honda Civic, a small sedan. So you want to just try and match that up to the size of a vehicle in the intersection. So I'd say we're pretty good there. And then lastly, what we're seeing on the left is a Google Street Maps view of this location. And on the right, we're seeing the camera's field of view. So what we want to do here is try and match up the view on the left with the view of the right. And this is just to help, it's to help automate the configuration. So this doesn't have to be perfect, but if you get it right, it's going to make your lives easier a little bit after. And it's just to help identify where north is basically, and where the camera's facing and what it's able to see. So if we take a look here, I mean, on the right side, we've got the apartment building, we've got the signals. I'd say we're pretty good here, which means the camera's facing north. Go ahead and click OK. We're going to set up our first detector as well. So you can actually set up to 9 different views across all cameras. That includes the turning movement count view. but that's something that was enabled rather recently. So if you have diamond or pentagon shaped intersections, you can go ahead and create different approaches there. In the case of setting up a detector, we do everything based on the approaches themselves. So if we wanted to set up this approach first, go ahead and click here. And if you remember how I said, if you get the orientation of the camera correct, it's going to help you afterwards. That's what it's doing here. It knows that this is the northbound approach automatically. It's labeled it Portland Avenue East northbound. So I'm happy with that. I got everything right. So we're going to go ahead and create our first detector. So we can we'll start with a vehicle detector. And depending on the configuration of the intersection and the timing plan, again, you can create lane by lane. We could create a single detector for the through movement, which is a more common setup. So we can go ahead and do that. So we're happy with that. We're going to choose the movement. We can name it. So let's say it's phase 5 northbound through. We're going to set the movement to be a through movement. We have a couple different options. We've got hypersensitivity mode. You can change the classification to look for just bicycles, for example. You can change the detector output to be a presence or a pulse. And you can also change delay and extension. And then you're also going to choose which channel that we tie everything to. So in this case, it's phase 5. So I'm going to look at channel 1, 2, 3, 4, 5. I'll just name that phase 5 northbound through channel 21. So we have created our first detector there. And we'd go ahead and do the exact same for the left turn lane, except we would have that likely phase, maybe in this case, phase 2, northbound left turn, channel 18. We can also go ahead and add a crosswalk. And again, the crosswalk is going to be set up in the middle of the crosswalk and ideally spanning the whole crosswalk. And again, that's going to be for some of the signal performance measures and the charts you can generate for occupancy during a flashing don't walk. Let me just say it's located on the south side of the intersection. And we've gone ahead and configured an approach. So we would go ahead and do the exact same thing for the southbound here, as well as the eastbound. So I'm going to do that fairly quickly so we can go ahead and get through to the turning movement counts, because I know we are running a little short on time. So I know this is our southbound. We'll create a detection zone here. And again, we'd have a separate detector for the southbound right turn there. In this case, it's a through movement. We're just going to leave the name, but we're going to go ahead and choose the channel for it. And then we're going to quickly jump through the eastbound approach as well. So under the assumption we have all of our detectors set up here, we can go ahead and set up the turning movement counts. So we'd go ahead and choose where the each individual approach and what we're looking at. And then when you set up the turning movement counts, what you'd like to do is just cover the crosswalks, because that tends to be a good entry and exit point. So this is actually going to be a pretty large turning movement count, but that's okay. You can see I'm just covering the crosswalks in the view for the turning movement count. And then the next thing you're going to do is set up the entry points and the exit points. Now, these don't have to be perfect. There can be overlap on them. And in the case of if there's somewhere with no median, sometimes people make a left turn and go through the entry point, but you still want to count that. Actually, good examples kind of right here. So you could You can overlap them, and the entrance and exit points are still going to be okay. And we'll do the same thing over here. And green is our entering the intersection, and red is exiting the intersection. Now, it does pull in the movements that we had, based on the movements that are available, it is going to automatically start to generate some. So we've got the eastbound U-turn. And again, this whole line is going to be what we assume the movement to be. Once the heat maps are generated, we get a better idea of exactly what that looks like. But with a bit of practice, you can know exactly, or at least have a good general idea of how to draw the turning movement counts. And again, this is our southbound left turn, our southbound right turn. And I do see here that it's actually mislabeled some of these. What we want to do is go through and label them properly. It does typically generate the proper labeling. But again, that's how you set up the turning movement counts, and that's how you get the result we saw earlier in the TMC page. There's also an expert mode for more unique configurations. I think I mentioned earlier, if you wanted to count bikes in the pedestrian zone, we can go ahead and use expert mode to set those up. That is something that's only available to the Miovision team currently, and that's just because it gives you full customizability of everything, and it's quite powerful, but you could also break things very easily. Not permanently, of course. In this case, I'm going to discard the changes because I don't think the region would like the changes I've made to this intersection. But that gives you a summary of how to go ahead and configure an intersection there. Just going to jump back to our slides here. So we do have a help center available online. We've got a hardware knowledge base. We've got a traffic link portal knowledge base, as well as a video hub that does have some pre-recorded sessions that go into configuration as well as installation. That's exactly what I'm talking about here, the video library, account management, actual hardware installation. So we do walk you through all of that. And I know I said we'd have about 10 minutes left for questions. It does look like we have about 5 minutes here. As we start talking about this stuff, I tend to get pretty excited about it, which, I've been doing this for a little while, so I tend to like to talk about some of the cool and neat things we can do with the platform. So that has eaten up a little bit of our time, but hopefully we can get to all the questions that come up next. All right, if anybody has any questions, you can go ahead and fire them off just in the chat there. Again, you can reach out through email or chatting with our sales support teams. I can see a question coming in from Jeff here. So Jeff asked, what were the purple boxes after the crosswalk? So those purple boxes, they were actually pulse detection zones. So they may be set up for, likely for signal performance measures, maybe for some possible like approach cameras to take a look at things. But they are pulse detection zones that can be configured within the platform. So they weren't doing any of the actual detection or actuation on the intersection. So hopefully that answers your question there, Jeff. The pulse zones can be used for a number of different things, and again, typically signal performance measures. Next up, we have another question. So is there any way to do passive pedestrian detection with this system? So Anthony, that is a fantastic question. And the answer is a bit of yes and a bit of no. You technically can do it, but solving for pedestrians using video detection is a problem we're working on. It's a very difficult problem to solve because when it comes to vehicles, you have a vehicle that's in the through lane, you know that they're going through. When you have pedestrians at a corner, for example, they may be waiting to go, they might be turned around on their cell phone, but actually waiting to go, call it south, when they're on the when they're standing at the eastbound crosswalk. So it's hard to know exactly what to actuate there. Again, something we are working on, something we have some pilots running on. It's just not something we'd want to productize and say, yes, we support this until it's a feature that has an accuracy we'd be proud of. I think is probably the best way to say that. So short answer, yes, we can do it. Long answer is I wouldn't recommend it right now. So another question coming in, is there a way to block out stuff in detection zones? In one zone that I made there was a light pole in the way, and is that a concern or not? It can be a concern. So it really depends on how big or how much occlusion there is there. So the one that you're referring to, there was a small pole, I think it was a Molinaro, that was actually blocking the road a little bit. So it can be impactful, but typically we are looking for the shape of a vehicle. So if we see a vehicle come into that zone and then part of the vehicle is occluded there, we'd still typically know that there's actually a vehicle there that was detected on its way in, and we wouldn't drop that call. I don't know the exact amount, but we wouldn't drop the call right away. So you don't really have to block stuff out. In the case of major occlusion, like an example of a tree that grew in the summer that we weren't expecting when we installed things in the spring, then you typically want to move the camera in the case of something like that. All right, so a question coming in from Tennessee. So Sean, the Smart Ways project, I wouldn't know off the top of my head if you guys have access to the TMC currently. I would like to say yes, because I know it's a very helpful feature, but we can take a look at that and get back to you directly after the call here. And I know really we can get somebody, your technical account manager or somebody in sales to get back in touch and chat with you about that, okay? And then last question coming in from Michael. So can video be brought back over fiber or wireless for monitoring by a TMC? You can configure the Smart Link to be on a fiber network or broadband radio if that's what you're referencing here. By default, it does have a cellular plan associated with it, but if you wanted to use what we call third-party communications and there's existing communications in the field, you can absolutely use that as well. Perfect. I think that is all the questions that we have in here right now. I'll do a last call if there's any other questions. We're just hitting time right now, so yeah, last call for questions. All right, I don't see. Oh, yeah, okay. Last minute, Seth, you just down to the wire. Can the Smart Link be connected to fiber instead of cellular? Yes. Short answer is yes. You can go ahead and connect it to the fiber network that's located in that area, running through the cabinet, and you just have to configure it to run on that network. So Jose, I do see your question there. So creating a timing delay for ghosting of vehicles near bridge or reflective structures, a good way to resolve this issue. I'm not sure specifically what issue you're referring to there. What we can do is get back to you just after the call here, and we'll make sure to get that answered properly for you, okay? Perfect. Well, thanks everybody for joining me today. I hope that was an insightful and informative session. And if there's any other questions, feel free to reach out to us, and we'll be happy to answer them. As I'm sure you've learned today, I'm always happy to talk about Miovision products, hardware, software, and some of the cool things we can do with it. Hope everyone has a great Tuesday, and thanks for joining us. Take care.